Class of Mundos. Hi, it's Mr. B. I'm going crazy because I don't have any kids in my room. Anyways, last couple days before Christmas break, we have been talking about this idea of adding and subtracting fractions that do not have common denominators. Now, we know that when we add and subtract fractions, the denominators must be the same. Remember, the denominator, the number on the bottom, tells us how many pieces it takes to make one whole thing. Okay? When we talk about sevens and thirds, we're talking about pieces that are different sizes, right? If we got something divided into 7 and the same thing divided into third, those pieces are going to be different sizes. We can't add and subtract those together. They're not the same. We've got to get them to be the same, then we can add and subtract them, okay? So, the first thing we must do, for example, 17/7 minus 5/3, is we must get the denominators the same. And we use factors or multiples to get that, to find one that they share, right? We need to find one that they both have. So we're going to use multiples. In other words, we're going to times the number by 1, by 2, by 3, by 4, until they match. I always start with the smaller denominator and see if one of the multiples is actually the denominator of the larger denominator. Because if it is, then I don't have to change the other one. If it's not, I have to change them both. And you'll see what I mean. So I'm going to start with doing multiples of 3. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. And we jumped right over 7, didn't we? So we can't do it. We have to keep on going. We're going to have to do multiples of 7 also. So I usually run them out to 5. So we've got times 1, times 2, times 3, and we're doing 3. Times 4 is 12. Times 5 is 15. Then I go over to my larger one and I do it and see if I run into any of these numbers. 7 times 1 is 7. 7 times 2, 14. 7 times 3, 21. Well, I'm already bigger, aren't I? I didn't hit any of these, and I'm on to 21 here, and I've only got 15 here. So I'm going to keep running my smaller ones. Let's see. 1, 2, 3, 4, 5. 3 times 6, 18. 3 times 7, 21. And there it is, 21. Ding-a-ding-ding-ding-a-ding-ding. 21 is the denominator. Now I got to rewrite the whole problem, right? I'm going to rewrite this problem with 21 as my denominator in both fractions. Okay? Because that was a common. I had 21 here and I ended up getting 21 here. Now whatever I've done to the denominator to get 21, I must also do to the numerator. So what did I do to 7 to get 21? I multiplied it by 1, 2, 3. So 7 times 3 is 21. Now I must also multiply the numerator by 21. Okay? So I'm going to do 17 times 3. 7 times 3 is 21. 3 times 1 is 5. Plus 2 is 51. So this becomes 51 over 21, right? Now, what did I do to this 3 to make it 21? I times it by 1, 2, 3, 4, 5, 6, 7. 3 times 7 is 21. So I must also multiply the numerator by 7. 5 times 7 is 35. Now I've got a denominator of 21. In other words, the piece that I'm working with is divided into 21 pieces, right? This fraction is divided into 21 pieces, and so is this one. That means the pieces are the same size. Now I can add and subtract them, right? But I'm going to end up with pieces that are the same size. Okay? So I'm going to do 51 minus 35. 51 minus 35. Watch me closely, class. Where do I start when I subtract? The top of the ones, I tell you. You start at the top of the ones. Top of the ones, right? 1 minus 5. This is not 5 minus 1. Please don't do that. 1 minus 5. I cannot do that. I must go next door and borrow. Now 11 minus 5 is 6. Go to the top of the tens. 1 minus 3 is 1. You end up with 16 over 21. I know it's a lot of work to get one answer. I know. Kids look at these problems and go, oh, it's going to take me forever. This isn't about doing 100 problems. This is about being able to do 1, 2, or 3 and get them right. Okay? I don't care if you do 100. I don't care if you do 1,000,000. Right? I don't care if you do 2. If you do 2 and get those 2 right, I'm good with that. I really am. You guys all have, papers that look like this at home, right? You've all got these. I don't care how many of these are done. I truly don't. If you do 4 of them and they're correct, I'm going to be happy, right? If you do the whole thing and they're correct, I'll be really happy. But if you can do 1 or 2 or 3 and get them right, that means you got it. You don't have to do 100 of them, right? Just do 1, 2, or 3. I will tell you this, though. The more that you practice them, the faster you're going to get, right? So if you want to take a little time and practice, that's good too. But if you understand the concept and you understand how to do it, and you can do 1 or 2 or 3 and they're correct, man, that's what we're trying to do, right? That's all I expect. All right, everyone. Stay safe. One more lesson till Christmas break. All right. Take care. Bye. If you have any questions, message me. Bye.